Today, Scatterplots, the second day I can enter in data in my graphing calculator. I can make a scatter plot on the graphing calculator with a least square regression line. I can find the correlation value. Alright, so let's get going on this one. First of all, let's look at the line of best fit. That is the line that closely follows the data. Least square regression line, LSRL, is the most common line of best fit and uses the averages. Correlation coefficient, we're going to say how close the data is to that line. It's going to be somewhere between -1 and +1, and keep in mind that the closer to -1 or the closer to 1, the more accurate the information is. Then you have your interpolation. That's the process to predict between the points of data, and then extrapolation is the process to predict beyond the points of data. Alright, so let's get going on this one real quick here. We're going to have some data about the defibrillator and the survival rate from someone who had a sudden cardiac arrest. So let's enter in this data. Now, as a simple reminder, to put that in there, you're going to go to Stat and then Edit. So let's hit Stat. Let's Edit, Enter. And then we have to eliminate the information that might be in there. So we're going to clear out, and let's make sure we hit clear for L1 and L2. So scroll up to L2, hit clear and enter. Scroll up to L1, hit clear and enter. And then let's enter in this data. I'll put it on pause. Alright, now that we have our data in there, let us try to figure out the line of best fit that we're going to be making. So in this particular case, we're going to make the line of best fit. We're going to hit Stat again. So I'm going to write down Stat for a second time, hit Enter for Stat. And then we're going to scroll to the right to Calc. So to the right to Calc, so scroll to Calc. We're going to go down to number 4, linear regression. So we'll go down to linear regression. And that is with the AX plus B. And then we're going to enter in L1 and L2. So on how we're going to do that, we're going to hit second and L1. And then don't forget the comma. And then second, L2, and a comma. So L1, comma, L2, comma. And then we will enter in our information for the Y value. We want it to be Y equals, using L1 for my X values, L2 for my Y values. And that will create the slope as well as the Y-intercept. So we will do that by hitting vars, which is variables. So variables. We're going to scroll to the right for the Y variables. We're going to enter in enter for functions. And we're going to enter in for Y sub 1. So there's our Y sub 1. Now let's perform it by hitting enter one more time. And you should see that we are in linear regression. We're using Y equals AX plus B, but we know that A value is the slope. And then the A value is given, the B value is given, and the R value represents the correlation coefficient. So we will have a equation that is Y equals AX, so negative 8.93. We'll round it to the second decimal spot. X, and then plus the B value, 99.01. And then we will also look at the correlation, which is a negative 0.9719. Now, if we want to graph it, we will go to Zoom, and then Zoom Stat, number 9. So hit zoom and zoom stat. And you'll notice that our dots are on there as well as a line using the information we programmed it in with L1 and L2. So here's how you're going to draw this. Draw the line first. Then put the dots, or in this case the squares of data, on or near the line as they are located on your screen. Like so. Next one, we're going to look at hot air balloon data. So let's enter that in. Now let's just remember stat, edit, scroll up to L2 and clear it. Scroll up to L1 and clear it. Entering in the data as you see it. All right, after you have the data in there, we're going to do the same information as we did before. We're going to go to stat. We're going to calculate using number 4, so linear regression. We want to use the data for x for L1, comma. The y values are under L2, comma. We want to use the y variable, so we'll go to vars, y variables, functions, y sub 1, and we'll hit enter. At that point, our equation is ax plus b, so negative 29.33 x plus the b value of 396.11. We're going to describe it as a negative correlation. The reason why is the slope states that it's negative. The correlation is the r value, negative 9.9976. The correlation could also state the negative. Now we could go to zoom and number 9 for zoom stat. Graph the line as you see it. Put the dots that are on the line, and you'll notice that these dots, I think every one of them is touching the line in some form, and that's why our correlation is so close to -1, because the information is close to the line. The last thing we have to do is put 12 in for x. So x equals 12 into the equation of y equals negative 29.33 x plus 396.11, putting 12 in for x. So we will have y equals negative 29.33. We'll put 12 in for x plus 396.11. Put that in your calculator, and you should get an answer of y equals 44.15 feet. And I should have it as an approximation, actually, because of the rounding answers. And feet is my unit of measure. All right, last one. We're going to go to stat. We'll edit, clear, and then enter in our data. So entering in our data. And then our data for the second for the y values. All right, let's go to stat. We're going to calculate. We're going to go to linear regression. We're going to put in our L1 list, comma, our L2 list, comma, and then we're going to put on our variables for y variables under functions, y sub 1, hit enter, and our description of this one will be y equals 3.48x minus 1118.28. Our regression correlation coefficient is 0.8634. And our description, it will be a positive one because the slope is as well as the correlation is. Let's go to zoom and then down to number 9, zoom stat. And you'll see our line being drawn with our graph information on there. Draw the line first. And then put the points of data according to the screen you see. The last thing is we're going to put 770 in for x. Put that in your calculator, and you should get an answer that is somewhere between 754's data and 781, so somewhere between 1700 and 1400, so maybe 15 something. Put it in there and you're going to find out that our approximation is 1561.32, and I don't know the unit of measure, so we'll just put units. All right, there you go.